so that we enter in 12th with full confidence, right? Chalo. So apna likha r prime x. This is r minus. Now what normally happens with r minus? This r minus goes and attack on r prime, and this x is out. So what is the product of this? R prime. अब यहाँ पे खास बात क्या हो गई? R prime. You are the one who is going to choose R. You are the one who's going to choose R prime. All power to you. Everything you are going to decide. Is it clear? So let's say, for example, you want to connect CH3 on CH2, CH3. So maybe I can do this way. I can start with CH3, CuLi, CH3, and react on CH3, CH2, Br. So what will happen? This will go and attack. This is out. So what's my answer? CH3, CH2, CH3. And that's the only answer. Best part is that's the only answer. No other answer. Let's say tomorrow आपको लगता है नहीं मेरे को ये नहीं बनाना, मेरे को ऐसा कोई compound बनाना है. CH3, CuLi with CH3 with a 5-membered ring. जाओ attack करो and get this compound. Check please. Whatever comes to your mind, you can devise, design, get the product. So it's like customized solution of any alkane. This reaction is such an important reaction, right? Now the question here is, how will I get R2Cl? I think this is the question which is currently in your mind. Sir, ये कैसे बनाएंगे? ये भी तो एक, this is itself a task, right? How to get this thing? I'll talk about this also. First, you write this part. Just note down this. How to form this? I'll discuss this also now. Don't worry. First, you note down, please. So tomorrow you come across a question, and this question I'm quoting from ITJ examination. Similar question almost. I'll not say exactly same, but yes, to some extent same. What is the product? Can you give the product of this question? ऐसा question JEE exam में आ चुका है पहले. Can you tell the product? What is I have written here? This 2 CuLi means this 2 times on CuLi. So what is the answer? Here is it. You solved a JEE question. So what's the answer? Answer is this will go and join where? Join on CH2 and a 6-membered ring. आ गया? ये आपका आंसर हो गया. नोट कर लीजिए. समझ में आया? अब देखो कितनी पावरफुल रिएक्शन है. Think about an alkane, it will give you. So powerful. Akshay, Arjun, Niharika, and Arav. Is it clear to you why this reaction is so special? Why Wood's reaction is so, what do you say, like basic reaction?
So I didn't understand why R minus is the reactive part of that reagent.
Okay, sure. That's a good question. Let me revise it. Can you recall RLi, RMgX, R2 zinc, R2 cadmium, R2 CuLi from the last discussion, last class discussion?
Yes, sir.
In all these cases, what we discussed, they are all linked with metals. Hence, there will be 2 components, okay? One is negative, other is positive. And that is how R minus is the reacting component of it, okay?
Okay, sir.
And if you take any of these members and give them active hydrogen, they will always be willing to pick active hydrogen from RH. So that's a direct metal form of any RH of your choice. So Franklin reaction, Coriolis synthesis is one of the very useful reaction. And इसकी जितनी practice कर सकते हो करो, because पे question exam में आने का. If you ask me alkane, tell me one thing, sir, which is most important, or 2 things. One is this, one is Kolbe's reaction, or Kolbe's electrolysis, right? जिसको आप कोप बोलते हो, ठीक है?
So what happens to everything else in the reaction, like the other R and X and CuLi?
Name of this compound? What is IUPAC name of this compound, everyone? It's a 5-membered ring, it's a 6-membered ring, and then CH2. How will you write? What is the main ring? Phenyl to nahi, phenyl mein to 6-membered ring hoga na beech mein. So which is a big ring? Which is the main ring of main chain of this? Huh? Cyclohexane. Cyclohexane is the main chain. And cyclohexane पे क्या लगा हुआ है? Cyclopentyl methyl. Cyclopentyl methyl. Right? Are you understanding?
Cyclopentyl methyl.
Cyclohexane will be the complete name. Yes, coming to Arjun's question. Yes, Arjun.
So what happens to everything else in the reaction, like the other R and CuLi and X?
They will be just byproduct. Okay,
Okay.
they'll be the byproduct of the reaction. Now I'll come to the next important question, which was how do you form R2COLI? ये भी तो समझना पड़ेगा कि R2COL बनाओगे कैसे भाई? How will you make R2COLI? That's also to be understood. So please note it down, then I'll go to the next part of this story. Is it done? Written? Great. So write down, how do we form R2COLI? Let's try doing it. Here is it. So Rx with 2 units of Li in dry ether forms RLi, and RLi 2 units with copper iodide form R2COLI. This is the requirement for further reaction. So third part we have done. Look at the third reaction. That's what we have done. Yes or no? ये आपने अभी किया है मेरे साथ. In this, who is going to attack? R minus is going to attack on R prime. X is out. Formation is this. ये पता है अपने को? At the same moment, how to form R2COLI? These are two steps. Okay. अब इसके स्टेप्स में आपको एक क्वेश्चन के फॉर्म में पूछ देता हूँ, तो आपको जल्दी प्रिपेयर हो जाएंगे. CH3Br प्लस लिखिए, ड्राई ईथर, 2 units of A gives C plus LiI. C plus Br gives D. Find out ABCD. Find out ABCD. Try. First, you note it down. Try to understand this. Try to answer this question. Automatically, you will never forget this. Try to answer. So A is what? CH3. Li. B is LiBr.
C will be CH3
Hmm.
and D will be
CH3 on CuLi CH3.
yeah, so CH3 to Cu.
Correct.
And D will be
This attacks your Br.
cyclohexane.
Very good. कर लेंगे सभी लोग. Please note कर लीजिए. समझ में आ गया? So I've given a question so that it comes with clarity in your mind, right? Any difficulty in this? Be ready to answer such questions. These are one of the most important questions of the topic which we're doing right now called alkane. अभी हम alkane पे हैं, alkene पे नहीं गए, but alkane में आप पूछोगे दो important reaction तो एक ही होती है, और Kolbe's electrolysis, right? These are two most important reactions.
Sir,
Yes.
so why do they use copper iodide?
Copper iodide. See, purpose of copper iodide is to get a compound. See, why? What is the whole purpose of this reaction? Just try to observe. You're trying to create something which is R negative, right? अब R negative आपके पास, you have multiple method to form R negative. Somebody can say RMGX भी तो बना सकते थे, right? Why not I'm taking RMGX? The problem with RMGX is more interested in active hydrogen only, right? So it will be very much reactive. So you have controlled the reactivity using copper part. When copper comes in play, the reactivity of R minus is controlled. It's like a controlled reaction, not random reaction कि कुछ भी बनाना शुरू कर देगा. If you have R negative of RMGX, or for instance RLi is even reactive than RMGX. So if you ask me what is the sequence of reactivity, I'll say RLi comes almost on the top. RMGX will be coming after that. Okay. R2CuLi will be even after that. Okay. And then R2 zinc will be, and R2 cadmium, they will be at the bottom. So this is the order of reactivity. Fine. Everything cannot be used everywhere. Is that clear? Akshay, is it clear?
Yes, sir.
Okay. Yawning. Which exam you have tomorrow? English. पढ़ लिया होगा सारा कुछ. यही पढ़ा है. इधर ऑनलाइन वालों ने पढ़ लिया? नहीं पढ़ा. अर्जुन,
No, sir.
Okay. Arav,
No, sir.
Niharika? नहीं? Okay. चलो, clear है? Conceptually sound? चलिए आगे बढ़ते हैं. Let's progress further in our discussion. So choreosynthesis we can do. Now, you can look at this kind of question. I have mentioned R prime X should be a primary halide. I said 2 degrees so and 3 degrees not possible, right? So primary लोगे तो best है, but 2 degree में भी चल जाता है. And the alkyl group are in the organic compound may be primary or quaternary, for example. तो ये आपको समझ में आ गया, ऐसी क्वेश्चन कर पाओगे. इसमें कौन रिएक्ट करेगा इस पे? Just see the question. Can I say in this case this is CH3 and this is going to attack where? कहाँ गया? यहाँ. Correct? So ये आपका आंसर बन जाएगा. क्या मेरे को रटने की जरूरत है? I don't think so. It's very simple. Please note down this reaction. फटाफट नोट कर लीजिए अपने रेफरेंस के लिए. Quickly. Is it required to write down also? I think it's clear, right? Understood the concept, right? So I'll just see some example quickly. I'll remove it. See the next one. Look at this one. So these use cases, once you see, you'll become more comfortable. अरे अच्छा ये होता है, चलो simple है, मेरे को clear हो गया. So see what they're doing. They're taking some halide, lithium, copper. ये बन गया अपने पास. This is going to attack where? Here. This will be out. Join कर दिया compound में. Correct? कर लोगे? ये note कर लो. This is a good question. Please note down end to end. पूरा note कर लीजिए for completing your notes also. Write products also. 3-methyl octane, all those things. एक बार note कर लीजिए quickly. Don't take much time. Take 30 seconds. Be very, very quick. Super quick. क्या बात है, आज तो अक्षय दिख रहा है इधर.
So what?
Akshay is now in the frame today
So
because
camera.
Arjun is attending online. I think that is the reason. अक्षय और अर्जुन की जोड़ी is करण अर्जुन की जोड़ी. Arjun, I can't see your face. I can see some like
Sir, the
dark.
sun coming from the side.
Okay, okay, fine. You have any doubt? Please ask. Right?
Yes, sir.
Is this clear? Simple reaction. Understood the process also, everyone? Conceptually समझ में आ रहा है आपको क्या हो रहा है इसमें? So ये देख के आपको डरने का नहीं, सीधे समझ जाओगे यहाँ पे क्या हो रहा है, and then you can do it quickly. Moving forward. Moving forward. कर लीजिए, कर लीजिए. I request all of you to please be more and more habitual to write things. Okay? Don't save pen, paper, ink. Don't be conservationist in these 2 years. After that, आप save कर लेना. Okay? But अभी, the more you write, more comfortable you'll become in understanding concepts. So जितनी practice हो सकती है उतनी करो. Just for information, Arjun has attempted almost 6 to 7 GOC tests and he has shared the result. So all of you should do that. Okay? 6, 7, yes, 6, 7. 6, 7 कर रहा है. ठीक है. Good. चलो आगे बढ़े. You should take motivation from your peer group. एक बच्चे ने किया, बाकी लोग भी कर सकते हैं. ठीक है. हर किसी के अंदर कुछ ना कुछ खास बातें होंगी. Try to learn from your peer group. जैसे अक्षय के अंदर बहुत सारी खास बातें हैं.
Yes, sir.
So write down the heading. Call-based electrolysis. Okay. Call-based electrolysis. Now there are 2-3 terms we should understand first. What is electrolysis? Anybody? What do you mean by electrolysis or electrolytic decomposition? Akshay, can you answer? Yeah, Arav is answering. Yes, Arav.
So when you pass like current through the aqueous solution.
Okay. Or can I just generalize it to any electrolyte? Aqueous solution जरूरी नहीं ना, कुछ भी हो सकता है. Molten भी तो हो सकता है, right? Okay. So what will happen because of that?
So the compound will split into its ionic part.
Okay. So ions will be produced or it will break down. Okay. Now just see certain examples. So I'll take one very famous example you must have done in 8th, 9th standard or maybe earlier also. There's one example called molten NaCl. Have you heard of this term? Molten NaCl, right? right? So this consists of Na plus and Cl minus ion. But before that, let me just write definition of electrolysis. Conversion of electrical energy to chemical energy. Conversion of electrical energy to chemical energy is known as electrolysis as a process, right? And the cell which does this is called electrolytic cells. Okay. The apparatus, electrical to chemical energy. The apparatus which is used is called electrolytic cell. The cell or the apparatus for this is known as electrolytic cell. Now there's a topic called electrochemistry where we'll discuss everything in brief, not brief, in much more detail in 12th standard. Electrochemistry पूरा topic ही इसी पे जहाँ पे आप cell पढ़ोगे सिर्फ. You will learn about electrochemical cells, electrolytic cell, galvanic cell, fuel cells, then inverter batteries, lead storage batteries, everything will be taught. Okay. But for our discussion right now, electrical energy to chemical energy is more than enough to start the discussion. So this kind of setup is there. These are some rods inserted which are called electrodes. And let's say we keep Na plus and Cl minus in ion form inside, considering NaCl situation. So as you know, this is a positive terminal. This is negative terminal. Okay. So this terminal is known for sending electrons. You know that. And this is the flow of electron, right? How I will emanate, I will be having exactly reverse direction. So these fundamentals should be clear. This is called positive electrode. This is called negative electrode. Any difficulty in this part? Online people? Is it clear? So please draw this structure. Fatafat draw kar lo. Now, electrons are reaching here on the right side, let's say. If electrons are reaching here, Na plus will go and grab electron and will become and deposit as sodium solid. So I'm calling it rod 1. This is 1. Make sense? Simple si baat. Even this, if you want to do this experiment at home, you can do it, but you have to do with not 220 volt wala electricity, a normal cell wala setup you can use and do it. Okay. And again, yeah, I'll tell you what all is possible, right? Now, second side, what is happening? This is Cl negative. Now, Cl negative will be running to this part, and this will release chlorine gas on this particular rod. So the gas cannot stay on the rod. The gas will escape, right? It will just leave. And electrons will not fly in air. So they have this circuit to move. Simple. So the second equation I'm going to write is half Cl2 plus electron. They cannot be anything half, multiply 2, make it 2, make it 2, and write a final equation which looks like 2 Na plus 2 Cl minus gives 2 Na solid plus chlorine gas. How many moles of current have been passed? 2 moles of current. 2 moles of electron are required for one reaction. Okay. Later you will know that this moles of electron is also known as Faraday's. So this is called Faraday's. In electrochemistry, we'll discuss these things in much more detail. But you can know these terms at this moment also, not a big deal. So you're passing 2 Faraday's and you're depositing 2 moles of sodium solid whose N factor is 1. Hence, its gram equivalents are also 2. Because moles into N factor is gram equivalent. So later you will learn a rule that the number of Faradays you will pass will be the same as number of gram equivalents deposited or liberated as a golden rule for any electrochemistry problem. This will save you in all difficult situations. Question comes, how many grams? You will say how many gram equivalents? Same Faradays. Done. What is Faradays? Faradays is nothing but moles of electron. So if you pass 3 Faradays of current, 3 Faradays of charge, how many gram equivalents will be deposited? 3. If you pass 4, 4. If you pass 2, 2. So what is Faraday? Here you see, this is 2 electron. When I multiply 2, this became 2. 2 electron got cancelled. I'm calling it 2 moles of electron is giving you 2 sodium solid. What is sodium N factor? Plus 1 से कहाँ पे जा रहा है भाई? 0 पे जा रहा है. Drop 1 का है. तो n फैक्टर कितना हुआ सोडियम का 1 plus 1 to 0, n factor is 1, n factor ध्यान है, and moles into n factor is called gram equivalent. Please note down. So the rule is simple, Faraday is equal to gram equivalent. Anyway, let's not go into discussion of electrochemistry, come back to our organic discussion, but if you know the concept, it becomes logical to understand things in better way, rather than just mugging it up. That's why I gave you some idea about this process. Now coming to your question, our discussion is on Kolbe's electrolysis. So Kolbe as a scientist is doing some reactions on certain compounds, and he is getting certain alkanes, alkenes, and alkynes. We have to see how. How many of you can tell me on number 1 rod, the reaction which is happening is oxidation or reduction? The first one, it's a reduction. So right now, this is reduction. And the second one is oxidation. And please note down, every time reduction happens at cathode and oxidation always happens at anode. Always. This is the truth for all the cells that exist in nature. In nature as in what, right? Every cell. ये कभी change नहीं होगा. So what I'm telling once again, listen to me carefully. Anode oxidation, cathode reduction. Polarities may be positive, negative changed, but this will never change. So if a question comes, they ask cathode, anode, reduction, oxidation. Polarities can be plus minus or minus plus, but this is fixed. This is always fixed. Okay? This also you should know. Now, at least you have some sound background to understand electrolysis. Otherwise, ऊपर से निकल जाता, मैं एक reaction के form में बताता और कुछ फायदा नहीं होता. Now you know something. So reduction is happening on cathode, oxidation is happening on anode, and this is how reaction takes place. Arjun clear? Niharika, Arav, Akshay, Sham, Adya, Sanjana, Chinmay. Everyone, is it okay? Comfortable situation? कोई डाउट, कोई प्रॉब्लम तो बताइए. कोई प्रॉब्लम नहीं है? All right. आराम से ड्रॉ कर लो, लिख लो सारी चीजें, then we proceed further. Done? Can I remove this? Yes, you have any doubt, Arjun?
No, sir.
Okay. सिग्नल खेल रहे हो दोस्त के साथ. चलो, फिर से एक बार हेडिंग लिखते हैं. Kolbe's electrolysis. ठीक है. Now I'll take some compounds. You please try to understand. आप लिखते चलो बस. CH3CO minus K plus. And for this particular reaction, I'll complete for alkene, alkyne also now. Everything, पूरा वो complete हो जाएगा. Setup ही मतलब इसके लिए, right? Because this will come again in alkene, this will come again in alkyne, so we can do it once for all. Note down all 3 compounds. Okay. So in all these reactions, one thing is common. As you can observe, these are all salts. And these are salts of some acid, right? That is common thing. In certain cases, you have just one COK, like first and the fifth one. In other three cases, you have two COK, right? Now I'll just show you one and then I'll ask you and you will complete other yourself. So let's take this situation, this particular compound. Now, first of all, look at this compound. This comes from the acid, which is CH2, CH2, COH, COH. Anybody knows the name of this acid? Which acid is this?
The butane dioic acid.
Butane 1,4-dioic acid. That's fine. But what is the name of butane 1,4-dioic acid? Is the IUPAC name. What is the general name? Like normally what we call this acid. Have we done Ohm's gaps in your class?
Yes.
Can you recall Ohm's gaps kind of thing? OMSGAPS. Somewhere in your notes, please check. O as in oxalic, oxalic COH connected on a COH. Then एक CH2 बीच में डाल दिया आपने. This becomes malonic. Then you put two CH2s in between. Then it becomes succinic. Then you put three CH2s in between. That becomes glutaric. Then you put four CH2s in between. Something like this, between two COH. Then it becomes adipic. Okay. This is called oxalic, malonic, succinic, glutaric, and adipic. Please note down. Oxalic, O, M, S, G, A. इसके बाद दो आते हैं P और S, pimelic and subric, not very important. This is called Ohm's gaps. These are all dioic acids. And there's a simple trick to remember all dioic acid name, Ohm's gaps. Okay. So which acid is this? Now can you tell? Which acid is this? Succinic acid. So write down. This is succinic acid. So this is succinate. This is succinate, right? Because it's a salt, right? Similarly, look at this one. Where's the double bond coming up? These acids. So for this also you should know the name. CH, double bond CH, COH, COH. If it is having cis form, अब cis और trans आपको बताना नहीं पड़ना चाहिए, आपको पता है cis और trans क्या होता है. Can you draw yourself? This is called maleic acid. And if it is trans, it is called fumaric acid. Okay. So how will cis look like? C double bond C, HH same side, COH, COH same side. इसका नाम क्या होगा? Maleic acid. This we have done in acidity. If you recall your notes of acidity, we have done this maleic anhydride formation and वहाँ पे H निकाला था. इसका K1, K2 डिस्कस किया था क्लास में. Anyone remembers? Sham remembers? Anyone else? I'm not asking you know the answer. I'm asking like, have you heard of maleic word in my class earlier? Yes. Everyone online? So please find some time to revise things. Organic chemistry, the best thing is what you can do is you can revise for just 4 to 5 minutes after class. Anytime. Just 5 minutes, not more than that. Utna bhi kafi hai. But yes, as we say, if you're not doing it in proper disciplined way, then it's not going to give you results. So एक रूटीन बना लो अपना कि भाई कोई क्लास हुई 5 मिनट लगाना है, रिवाइज करना और आगे बढ़ जाना है. एक पैटर्न बना लीजिए. जैसे टेस्ट क्या है 30 मिनट, वो टेस्ट नहीं है यार, वो असाइनमेंट है आपका. दैट इज नॉट टेस्ट. अर्जुन आर यू देयर? सो दैट्स एन असाइनमेंट. टेक इट एज एन असाइनमेंट. कोई भी टॉपिक पढ़ा आज, घर पे जाओ, एक छोटा सा 30 मिनट स्पेंड करो, खत्म हो गया काम. इतना ही काम है. इट्स नॉट अ बिग डील. बट वो आपको रेगुलर बेसिस पे करते रहना है. ठीक है. देन यू विल डेफिनेटली गेट रिजल्ट. So this is succinic acid. Now what is going to happen? These are all anions. Just a common thing between all of them is all are anions. Now you please recall what we have done with our anion, which was written on rod number 2. कितने लोगों को ध्यान है? थोड़े पहले हमने किया है electrolysis, rod number 2. What is the equation written there? Can you recall? Cl minus giving Cl2 and electron, half Cl2 plus electron. Very good. Exactly same thing is going to happen for all of them. So see how what is going to happen. This is CO2. So this breaks as CH3 radical. Okay. तो यहाँ पे ब्रेक हुए, ये ब्रेक हुआ, रेडिकल रेडिकल फॉर्म हो गए, इसका एक रेडिकल इधर चला गया और इलेक्ट्रॉनिक बाहर निकल गया. ठीक है. So what will it form? CH3 radical, carbon dioxide gas plus electron. Any problem in this? Check the net charge. Net charge is -1. Net charge is -1. How the bond will break? Again, I'll explain. So between CH3 and carbon, there's a bond. Okay. You break this bond and give 1 electron to CH3, 1 electron to carbon. Between CH3 and carbon, this particular thing. 1 electron to CH3, radical. 1 electron to carbon. यहाँ पे radical बन गया. There is negative charge. That means 2 electron. 1 electron will be used to form a double bond, CO2, and the last electron is out as electron. Simple. Is the process clear? Can you say what will happen here? This will break, both will break. I'll get one CO2 out of it. I'll get another CO2 out of it. And मेरे को electrons यहाँ से भी मिलेगा, electron यहाँ से भी मिलेगा. But this is combined. So what it will form? CH2, CH2, radical, radical. In next case, what will form? This will break, break. This is going to break. This will give me CO2. This part will give me CO2. Here it will give CH, double bond, CH, radical, radical, electrons here and electrons here. In this case, radical, radical, CO2. Can I say simply 2 CO2? अब समझ में आना शुरू हो चुका है आपको? Why I'm writing 2 times? You can understand 2 CO2, 2 electrons. This time, radical, CO2, electron. कितने लोगों को समझ में आ गई सारी बात? Whatever is written is clear to you, conceptually sound. Please note down. Now what is going to happen? This CH3 radical will search for one more radical. So basically this reaction requires 2 molecules. So 1 mole radical, same process, and they club, form which gas? C2H6. So this is preparation method of ethane. This one is already radical, and there are 2 radicals present together. They don't want something outside, something from outside. They can join here itself. What will they form? CH2 double bond CH2, which is called ethylene or ethene. This one will combine, will form HC triple bond CH, which is called ethyl or acetylene, right? This one, these radicals will club. This will form a cyclic structure with this kind of bicyclo situation. Okay. And this one again requires, again requires 2 units. You can get this, this. So dicyclopropyl. Arjun, Niharika, Arav, Akshay, is it clear? All of you understand this? So we are doing exactly same thing in all the reactions. कुछ अलग नहीं कर रहे हो, सब में एक ही काम कर रहे हो. Radicals बना रहे हो, radicals को club कर रहे हो. Now there comes a valid question. Sir, ऐसा क्यों नहीं हो रहा है कि ये radical एक और radical आ जाए और दोनों join कर जाएं? See, like somebody can say, sir, CH2 radical, you get one more unit and they both form 4-membered cyclic structure also. You are correct. That also forms as a byproduct. But mainly this will be the product. Okay?
The unit itself, the bond.
Exactly. Unit itself bond is available, so it will form bond here. That will be the major answer. Minor answer can be 2 units can club and form a 4-membered ring also. So we can't rule out that no cyclobutane will form. Okay, we can't say like that. Is it clear? So if the examiner want to check your fundamental knowledge, they will hit on this part also. So they will give you multiple options, correct? And they can check whether you mark the right options or not. So for example, in this case, one option is I have radical here and clubbed inside. Somebody can say, no, something else you can suggest on this. So if you try, is it possible? It is something like I take one more 4-member and join like this. think it's like the C4 member on top and this joins here and this joins here. एक ऐसा difficult सा structure बन सकता है. Can you observe? Okay. Fine. Please note down. So this is all about call-based electrolysis. Alkane चाहिए, ये use कर लो. If you use CH3, CH2, let me ask variation here. CH3, CH2, what's the answer? If I use CH3, CH2, what's the answer? Which compound will form? C2?
C4.
No, if I use CH3, CH2 in place of this CH3, what will be the product? C4H10. C4H10. Because that will be CH3, CH2. Okay. This is clear. Let's say I put one CH3 hanging here. Then you can draw the product accordingly. तो वो सब खेल सकते हो आप, उसमें कोई दिक्कत वाली बात नहीं है, right? Once you know the concept, you can do anything. Now I can solve any question of call-based electrolysis of last 20-25 years. Answer will definitely come. Another question which is asked on this reaction is ratio of carbon dioxide to the ratio of alkane form. Just pay attention to those details. Pay attention to this detail. How many carbon dioxides are formed? 1 mole. To form C2H6, you need 1 more unit. That means 1 more set of carbon dioxide. So how many can answer? To get 1 mole of C2H6, how many mole of CO2 are produced? 2 moles. In this reaction, this is to this ratio is 1:2. Is it clear? Akshay, Arav, Arjun, Niharika? Yes or no? No, उस पे आ रहा हूँ मैं. यहाँ पे आ जाइए इस वाले में. हाँ, इसमें भी CO2 versus this compound ratios. Correct. So this case, this 2 CO2 and we are getting just 1 compound, right? Okay. Let's say you use 2 such units, this will become 4 and the compound will be 1. तो वहां फंस जाओगे आप. अगर मान लो मैं यहाँ पे इस क्वेश्चन में एक compound बना के दूं, ये. And then I ask what is the ratio of CO2 and this compound. What's the answer? This compound, 2 CO2s for this part. To form that, I need 2 such units. I need 4 CO2. That becomes 4:1. सोच के देखो. Is that clear? तो ये further up, उसके और end detail में चले जाते. Any problem with this? Fourth one is this. It's a bicyclo compound. What will be the name of this compound? Bicyclo compound naming we have done. Bicyclo 1, 1, 0. And how many? 1, 2, 3, 4, right? Butane. Bicyclo 1, 1, 0, butane. Can we understand all these pointers? Akshay, any doubts? Please ask. Arjun, any doubt? Arav?
No.
Niharika, any doubts? थोड़ा ज़्यादा डिटेल में गए हम लोग, but I hope you can understand all the concepts here without any problem. Any issues? Any difficulty? ठीक बात है. ओके, चलिए आगे बढ़ते. So can methane be prepared by this reaction? Can methane be prepared by this reaction? No, because methane has just 1 carbon. So we can't get it. Good. So methane cannot be prepared by this reaction. Answers are clear. RR ratio with CO2. Now, another part of discussion is pending, which is this. Let me explain you this part also. So the reaction is happening, whatever you have discussed, which is happening on anode side. We have ignored so far cathode side. So write down what happens at cathode. What happens at cathode? Because as you know, IIT exams are not giving you any benefit of doubt कि चलो ठीक है कुछ थोड़ा बहुत पता है तो चल लेता है. They want to understand whether you know the concept properly or not. So they can check 2 more points. Question can be ratio of carbon dioxide to alkane. You can answer because you know the first part. But if question comes, what is the ratio of alkane to hydrogen? Then you can start if you don't know the concept. So I'm just covering that part also. So what happens at cathode? Please write down. First thing is reduction happens. Reduction happens at cathode. Now, all 5 questions which we have discussed, we are doing reduction at cathode. The question is anode is clear, but what is there on cathode? So for all 5 questions, we are using aqueous conditions, right? Water is just a solvent base. So reduction happens for water. Note down, this reaction will occur. In all 5 cases, this reaction will occur. Reduction of water will occur. So the next question comes, what is reduction reaction of water? Do we know? Arjun, can you answer this question? How do we write reduction reaction of water?
So H plus and OH minus.
Nahi bhai. Anyone else?
Is it formation of hydronium ion?
Hydronium ion? No.
So like you're adding H plus to that, right? To water, so.
No, we are adding electrons, right? Because reduction. So answer is it will produce hydrogen and OH minus. Note down. आप ऐसे लिखते हुए. Just see. So we'll write like this. Balance kar lo. H2, 2 OH minus, 2 electron. How to balance? 4 hydrogen, 2 oxygen, 2 oxygen, 2 electrons, 2 negative charge. Everything is balanced? Check please. Everything is balanced? So this is how we write the expression. This is reduction reaction of water. So what's the learning here? Learning is for 2 moles of electron, 1 mole of hydrogen comes out and 2 moles of OH minus comes out. If at cathode 2 moles of electrons are involved, at anode also 2 moles of electron are involved. Now think about your first question, which was CH3, COO minus K plus. In this question, we had 1 mole of electron for 1 CH3 radical. ये mechanism याद है आपको पूरा? अभी किया थोड़ी देर पहले. So for 2 moles of electron, you get 1 more CH3, as in you get C2H6. That means 2 moles of electron will give you 1 H2, 2 OH, and 1 C2H6. And how much CO2? 1 CO2 will become 2 CO2. Again, write one line for this. So your case number 1, which was CH3COO minus K plus, 1 mole of ethane, ऐसे लिख लो. Ethane 1 unit. Hydrogen will be how much? बताइए, खुद बताइए आप. Hydrogen will be how much? 1 unit. Very good. Carbon dioxide will be how many unit? अभी किया थोड़े पहले आपने. 2 units. And OH minus कितना बन के आएगा? How much OH minus will form? 2 units. Very good. And remember, this OH minus will go with KOH. So can I say OH minus बोलो या इसको KOH बोल लो, एक ही बात है. Because K plus ऐसे घूम रहा है. So this is going with K plus. आ गया? This is again a question of IIT exam. Okay, these kind of detailed questions they can ask. Now, if I want to further create problem for you, I will go with a numerical question on this. I will give you CH3CO minus. I'll give you, there is a salt, which is a salt of dioic acid. I'll not tell the name. I'll give that salt's molecular weight. And then I'll ask, what is the change in pH? Because यहाँ पे OH minus reaction में आ रहा है. Can you think that deep? That is the next level. अभी वहां तक नहीं पहुंचते, पहले यहाँ तक समझ जाओ, इतने काफी अभी, right? So see, one thing you start and then go deeper. There are multiple levels, and that is how your thought process should be synced, right? Chale. So one thing is clear that OH minus is going to increase, and if OH minus is going to increase, you know this from your knowledge of ionic equilibrium, whatever you have so far. If this increases, log of OH minus will increase, and if this increases, minus of log of OH minus will decrease, and if this decreases, POH is something what we call this, that will decrease, and if POH will decrease, pH will increase. So this is the next question on the same. Please note down this also. Can you connect this? As the reaction progresses, more and more OH minus will form. If OH minus will form, log OH minus will increase, minus of log OH minus will decrease, which is called POH. This will decrease, and if POH will decrease, that means OH is going down, so H is improving. pH will be higher, right? Correct? इसके ऊपर इसमें कुछ भी नहीं बन सकता. These are maximum number of questions that can be asked. Numerical questions are kept aside. Understood the concept? Take a break. Already 3:05. Take a break of 10 minutes. Catch you at 3:16. You have done much more in depth for this, right? Now write down the heading. Chemical properties of alkane, and another write down halogenation. So basically we are now starting substitution free radical reaction, which remember GOC we said one part is not done here, we'll be doing in hydrocarbon. This is called substitution free radical mechanism. पहले इसको समझते हैं थोड़ा एंड देन मैं इस पे आऊंगा, फिर थियरी वगैरह बाद में करते रहेंगे, बट पहले मैं एक बार आपको कॉन्सेप्चुअली इसको समझा दूं पूरा, राइट? देन विल कम बैक टू दिस. सो राइट डाउन द हेडिंग. फर्स्ट यू राइट द हेडिंग सब्स्टिट्यूशन, सो दैट कुछ लोग भूल गए होंगे क्या होता है, तो एक बार रिवीजन हो जाएगा एंड देन विल टेक इट फॉरवर्ड फ्रॉम देयर. Substitution reaction. In grade 12th, once you enter, complete halides, alkyl halide portion, the substitution reaction. Alcohols, again, a lot of substitution reactions will be there. Phenol ether, a lot of substitution reactions will also be there. Post that, if you move further, in acid halides and all, again, that will be addition elimination reaction, which look like substitution. That's a kind of variety of substitution only. So this will keep on coming. Under substitution, there are two broad categories. So substitution can be, or other three broad categories. One can be SE, other can be SN, and third can be SFR. लिख लीजिए. Substitution electrophilic, E for electrophile, N for nucleophile, so nucleophilic. Akshay, Arjun, Niharika, please turn on your cameras quickly.
So my camera isn't working anymore. Like when I try to switch it on, it says there's an issue. So it
You
was
can
working
rejoin.
until...
You can rejoin the meeting.
Okay,
Yesterday you
let's
did the
just-
same. I think it worked.
Yes, I'll just do it once.
Electrophile, nucleophile, free radical. Under electrophile, we have done something called SEAR, which was for aromatic compounds. If you recall, in short, reactions on benzene, reactions on naphthalene. Can you recall these positions? Then reactions on anthracene, these positions. Reactions on phenanthracene, these positions, right? Then reactions on pyrrole, which position? This position or this position? कौन सा किया? Next position, right? Reaction on furan, oxygen याद है? ये question किया था. Reaction on thiophene. Okay. Alpha position. Reaction on 6-membered ring attached with a 5-membered ring. This position. These all substitutions we have done. We have done in detail. Check your notes. You'll find it. Okay. Aromatic compounds पे कैसे reaction करते हैं? How do we form EN? How do we write different structures? Okay. कितने reactions बनेंगे? इसका reason भी discuss किया था हमने, right? How many structures will form in this? How many will form here? Here 3, here 2. Can you recall these things? In class notes you'll find out. चलिए वो सब कर दीजिए. ये dot नहीं है कुछ. Yeah. Anyways, so this is SE part. Now coming to the next part, SN part. SN part is substitution nucleophilic, where nucleophile is involved in substitution. What is substitution? A group comes and replaces. So in electrophile comes and replaces. In nucleophile comes and replaces. In free radical forms and then replaces. So अब काम एक ही हो रहा है, right? But the mechanism is different. Mechanism is governed by E plus. It is governed by Nu minus. And it is governed by Fr or free radical. That is the key difference in all these cases. Okay. Now under SNU, there are streak of reactions which will come up. Lots of reactions. But this, I would like to open this bundle once you reach in 12th standard because it will be too much to carry. Okay. Because if you know this half-heartedly, it's useless. It is so enormous, so big and so elaborate that if you know half things, you will do mistakes only. आधा पढ़ोगे, इधर गलत करोगे, उधर गलत करोगे, कुछ भी सुन लोगे, कुछ भी कर लोगे, उससे कुछ होने वाला नहीं. So rather than knowing the half reality, you should know the complete truth. And hence, it is very much important that you understand this in a proper way. And hence, you should wait for 12th standard. यहाँ पे क्या क्या आएगा मैं बता देता हूँ. इंडेक्स लिखवा देता हूँ. SN1, SN2, SN2AR, SNNGP, neighboring group participation, SN1 prime, SN2 prime, SN which is AE. अब ये भी क्या होता है डिस्कस करेंगे. Okay, addition elimination which looks like substitution. So addition elimination which is actually substitution, that is this one, and many more. So as of now you can understand nucleophile will come and replace X, as you have seen in lithium aluminum hydride reaction. H minus comes, X goes out, RH forms. अभी क्या hydrocarbon में आपने वो एक SN reaction थी. Is it clear? Or let's say somebody gives you RX and they give you OH minus. ये आया, इससे अटैक किया, ये निकल गया, ROH बन गया. इतना तो समझ पा रहे होगे. This is simple. Arjun, still you are not there? अच्छा.
No, I left.
Camera.
It's still not
Okay.
working. Yeah.
Okay, fine. Is it clear, everyone? Niharika, Arav, Akshay, is it clear? Now coming to SFR, which is completely in 11th standard now, which is very much important for 11th standard. And this is substitution free radicalization, which we have to discuss now. So अभी आपको पूरा समझ में आ गया हम कहाँ पे हैं, क्या कर रहे हैं, ये हमें करना है. Okay. So the reaction of methane with chlorine in presence of sunlight or heat is a very, very vigorous reaction very quick reaction, unstoppable reaction, and it will stop only at the end. It's like इसको A से D तक जाना, वो D पे रुकेगा, B C पे मिलेगा नहीं आपको. Okay. So basically the process will be, it will go via CH3Cl, CH2Cl2, CHCl3, CCl4. Okay? It will go via this process. The process is same. Now there will be multiple steps. The same thing you do with bromine. This can happen. The same thing you try with iodine. So iodine will not show reactions as such because it's very, very slow reaction. Okay, almost not proceeds. Fluorine is very vigorous reaction. So this will break the bonds and all, right? So again, you'll not find too much of SFR kind of qualities in fluorine. So eventually this quality will be mostly seen by chlorine and bromine. If I consider alkane into perspective. Okay, just note down this much. That this reaction is mostly for chlorine and bromine, not for fluorine and iodine. Iodine is too slow, fluorine is too fast. So fluorine क्या करता है, break करके टुकड़े टुकड़े करके ऐसे compound के ना एकदम कुछ भी बना देगा random चीजें. So that's completely useless, right? You'll not be able to control any product and all. Hence useless. Chlorine and bromine, controlled reactions. You can expect the product, you can get the product. Iodine is too slow, it will be almost nil or na ke barabar. Is it clear? Arav, Niharika, any doubts, please ask. Now in any SFR reaction, there are 3 steps. IPT. IPT. I for initiation. Propagation. And termination. So write down, there are 3 steps always. Initiation, propagation, and termination. This is formation of radical. This is progress of reaction. This is like summarizing. By आप कोई ऐसे लिखते हो, ऐसे में क्या होता है, पहले इंट्रोडक्शन करते हो, टॉपिक क्या है, फिर आप डिस्क्रिप्शन लिखते हो, फिर क्या करते हो, उसको कंक्लूड कर देते हो. सेम लाइक दैट. तो रिएक्शन भी क्या होता है, पहले इनिशिएट होता है, देन डिस्क्राइब हो गया, प्रोपेगेट कर गया, देन एट द एंड कंक्लूड, टर्मिनेशन. Okay, it's the same thing exactly. Is it clear? This is how this reaction works. Now we have to go take a deep dive in this, understand and come out. This is the index. Is it clear now what we are doing right now? So we are doing substitution, under substitution, nucleophilic, electrophilic, and free radical. Under that, electrophilic you have done because it's in your course. Nucleophilic not required. It is in 12th standard. First topic. Free radical we have to do now. Under free radical, fluorine, iodine useless because fluorine is too reactive, iodine is too slow. So chlorine, bromine are left out. So chlorine, bromine we are talking about, and we have to understand each and every minute detail of these two reactions so that we can solve any question of this also. Okay, done. Shall we start? All of you have written these informations. Niharika, Akshay, Arav. हो गया इतना? Done. इधर पे सभी का complete है. Good. Let's proceed. So write down halogenation and reaction with chlorine. Reaction with chlorine. No need to copy everything. Just write what I'm telling you to write, right? So reaction with chlorine. One of the most important chemical reaction of alkane is halogenation, which is defined as the replacement of hydrogen atom by the molecule halogen mixture of alkanes, chlorines. You can read it. Okay, nothing great, but basic ideas clear. Now coming to the first part, chain initiation. Initiation means start karna reaction. So how do you start a reaction? You have chlorine. Now this chlorine breaks into radicals. So see, this is step number 1. This breaks, and this half arrow is used for radical reactions. Be careful, you cannot use this. This will be wrong. Okay, so please note down the first step. Note down please. Cl radical in presence of sunlight, which is H nu, or heat, which is delta. So free radical reaction का बड़ा hint आपको ये मिलेगा, या तो HNO लिखा होगा वहां पे या डेल्टा लिखा होगा, समझ जाना free radical हो सकती है generally speaking. When you get that, you will break it into two parts. You get two Cl radicals. Is it clear? एक Cl, like one Cl2 molecule has become now two Cl radicals. But in this process, you are spending some energy. And this energy is to the tune of 58 kilocalories per mole. That means to break this bond, I am spending this much energy. Don't you think this energy is a humongous amount of energy? From where it will come? From where it will come, this energy? यहीं से आएगी या फिर यहाँ से आएगी, right? What is meaning of delta H positive? Delta H positive indicate endothermic process. Endo means when you have to supply heat, right? And the source is delta or H2. With this process, chlorine radical is ready. Now, chlorine radical is very reactive. Any radical is very reactive for that matter. Let's say oxygen is given. What will it give? Oxygen breaks as O2 breaks as this. Okay, this kind of radical. इसको बोलते हैं peroxide radical. Draw कर लीजिए. Okay. How will nitrogen break? Sorry, 1 and 1. एक तो है वैसे इसके पास अलग से, but ये radical है. ठीक है? So radicals will form in this format only. How will this break? Sorry, ये half है, तो कैसे दिखाओगे आप? C, C, C and H radical. Right? How will this break? Okay, please note down all the cases. सारे लिख लीजिए आप. ये easy लग रहा है, but धीरे धीरे चीजें. How will peroxide group break? ROOR. Note down this, this one, this, and chlorine already is. इसके ऊपर भी there are some cases, but I don't think अभी इतनी जल्दी आपके पास सारे cases आएंगे. Yes. Yes, this is benzyl radical. Yeah, this is the most stable one because benzyl is very stable radical. Okay, this is benzyl. Any problem in this? Any issues in this so far? Any difficulty you are facing? No issues? एंड एक और चीज आप लोग सभी लोग थोड़ा इम्प्लीमेंट करो अपने अंदर की, जैसे बहुत से बच्चों से हम लोग इंटरेक्शन की है, मेंस में एडवांस में भी करेंगे. सो स्टूडेंट पैनिक ड्यूरिंग एग्जाम. पैनिक के तीन मेन रीजन होते हैं. पहला, आपने पढ़ा नहीं हुआ है, चीजें आपने पढ़ी नहीं पहले कभी, तो आप पैनिक कर गए. दूसरा, एक्सपेक्टेशन इज मोर, रियलिटी इज लेस. एक्सपेक्टेशन रियलिटी डेफिसिट, दैट्स अ पैनिक का रीजन. तीसरा, आपने एग्जाम पेपर देख के कुछ माइंडसेट लेके गए थे कि ऐसा पेपर होगा, पेपर वैसा नहीं आया, कुछ अलग तरीका आ गया, तो आप पैनिक कर गए. सो इन पैनिक सिचुएशन विल गो इन डिफरेंट डायरेक्शन ऑल टुगेदर. सो सिंपल आइडिया इज, रादर देन पैनिकिंग, हैंडल द सिचुएशन कूलली, कामली, आराम से आप समझ के सोच के देखो कि ऐसा नहीं जाना कि मेरे को इतने नंबर लेके आने. आप हर पेपर को एक नया पेपर मान के चलो. राइट, टेक एग्जांपल ऑफ एनी क्रिकेटर. लेट्स से सचिन तेंदुलकर की बात कर लेते हैं या विराट कोहली की बात कर लो. व्हेन दे एंटर फील्ड, दे विल स्टार्ट फ्रॉम जीरो ओनली. एवरी मैच इज स्टार्टिंग फ्रॉम जीरो. बस आप वो माइंडसेट लेके चलो. अभी आप ये मत सोचो कि मैं सचिन तेंदुलकर तो मैं 100 नंबर मार के आऊंगा अंदर. नहीं भाई, कोई भी कुछ भी हो सकता है. तो आप माइंडसेट अपना बहुत क्लीन एंड क्लियर रखो कि मेरे को करना है, मेरे को पता है चीजें, आई विल डू माय बेस्ट और लेट इट गो. राइट, तो उस तरीके से आपको चीजें बहुत स्मूथ तरीके से होना शुरू हो जाएंगी. व्हेन यू स्टार्ट थिंकिंग टू मच अबाउट द रिजल्ट, व्हेन यू स्टार्ट थिंकिंग टू मच ड्यूरिंग द पेपर अबाउट रिजल्ट, दीज थिंग्स विल क्रिएट प्रॉब्लम. और ये अवॉइड करना शुरू करिए, ये क्लटर है एक तरीके का, राइट? ट्राई टू कीप इट ऑफ, ट्राई टू इम्प्लीमेंट इन सम स्मॉल टेस्ट फर्स्ट। एक आधे घंटे का टेस्ट लिखते हो, उसमें दिमाग में कुछ लोड मत लो, आराम से टेस्ट लिख दो, देखो क्या आता है। एंड जितने भी टेस्ट मैं यहाँ पे बोलता हूँ कि आप डेली एक टेस्ट लिखो, उसमें मैं नहीं बोल रहा हूँ कि आपकी कोई प्री रिक्विजिट है कि आप कोई प्रिपेयर करके आओ फिर टेस्ट लिखो, नो। आपने जो पढ़ा है, जो क्लास में सुनते आए हो, पढ़ते आए हो, उसके बेसिस पर टेस्ट लिख के देखो हाउ मच यू हैव रिटेन, ओके, एंड दैट विल रियली हेल्प यू आउट। सो पैनिक, प्रेशर, ये सब वर्ड्स साइड में हो जाएंगे। आराम से आप ग्रो भी करोगे, सब्जेक्ट में एंजॉय भी करोगे, समझ में भी आएगी चीजें आपको। एक्सपेक्टेशन को थोड़ी कम करो, हार्डवर्क को थोड़ा बढ़ा दो। सो एक्सपेक्टेशन ज्यादा है आपकी खुद से कि मेरे को 100 में से 100 नंबर लाने, हार्डवर्क आप करते हो 40 नंबर वाला, नंबर आते हैं 50-60, तो उसमें खुश होना चाहिए ना भाई, ये सब ठीक है, तो उसमें दुखी नहीं होना चाहिए। अब आप हार्डवर्क कर दो 120 का, तो 100 नंबर अपने आप ही आ जाएंगे, ठीक है। सो ग्रेजुअली यू ट्राई टू मीट द रिजल्ट एंड योर हार्डवर्क, वो बढ़ाते जाओगे तो अपने आप आपका रिजल्ट भी मैच कर जाएगा एट सम पॉइंट ऑफ टाइम। एंड दिस इज अ क्रूड रियलिटी which nobody can change. So this is how things work, right? Is this clear? Now coming to the second part of the story, chain propagation. Propagation is basically movement. Okay, this comes in physics also, wave propagation, right? How waves move. So this is chain propagation. See this radical. This radical will attack on other edge and the CH3 is free. So this forms HCl as a product. Now the CH3 which is free can again go to another Cl and create further radical and form CH3Cl as one of the product. In this process, you have created one more Cl radical ready to attack. So you started with you started with 2 units. 1 unit is used here. 1 more unit will be attacking somewhere on some other HCS3. And then now you have more Cls coming up in play. So it's like 1 is becoming 2 is becoming 4 is becoming 8 is becoming 16 is becoming 32 kind of situation. It will keep on growing. And hence reaction go completely out of your control. And hence we cannot stop at any of the places like CH3Cl. Because CH3Cl will again be reacting with Cl, forming CH2Cl2. CH2Cl2 will again be reacting with CH2Cl2 with Cl, will form CHCl3. It will again react to form CCl4. Okay? That is why free radical reactions are kind of uncontrolled reactions which we cannot control, and hence it becomes very complicated to get any product from the middle. अंत में आप वेट करो, पूरा होने दो आराम से, you'll get CCl4. That's okay. But if you try to get something in between, that's very complicated. Hence, chloroform is not formed by this method. Chloroform इससे नहीं बनाते हैं, ठीक है? Chloroform के अलग methods हैं.
Like it still end up at CCl4 and PCM CCl4.
Yeah, you have to like remove Cl somewhere in the middle and then try to control the reaction, which is very complicated. Okay. Now see these two steps. You can see -1 and -23. This negative number tells that a lot of energy is coming out here. Okay, energy is released. And this shows a lot of energy being produced in the reaction. So once you strike the reaction on, once you start the reaction on, initially you need some energy, but later energy is being produced in the process. And that energy will drive the reaction further. Understand? And that is why this reaction go out of your hand. This is propagation step. I hope you have written this, this, and this with numbers. When I say this is important, please take it very seriously. So mono, di, tri, tetra is clear. Sanjana, Chinmay, Niharika, please start. Welcome everyone. Welcome to your own channel, Anuj Genius Labs. Welcome everyone to your own channel, Anuj Genius Labs. Greetings. For CnH2n plus 2 and tell me how many unsaturations come up. If you applied for this case, how many unsaturation come up? 0. Very good. Shabash. Next case CnH2n के लिए भी कर लीजिए और CnH2n minus 2 के लिए भी कर लीजिए. CnH2n, how much it is coming? And CnH2n minus 2, how much it is coming? 2. Very good. Clear hai? Any confusion in this part? Akshay, is it clear?
Yes.
Okay. So basically when you talk about this term, hydrocarbon you can divide in two parts one is aliphatic, other is called aromatic. Aromatic कर चुके detail में. What is aromatic? So aromatic is something which is cyclic, sp2 hybridized, planar, 4n plus 2 pi electron moving, that comes out as 2, 6, 10, 14 electrons moving, and complete delocalization. Right? This is how you draw the structure, isn't it? That's how you talk about aromatic compounds. And apart from aromatic, others are known as aliphatic compounds, right? So aliphatic hydrocarbon, aromatic hydrocarbon. Can you suggest some example of compound like benzene, like naphthalene? These are all aromatic compounds. Anthracene, 3 ring बना दो. फिर anthracene. They all are aromatic compounds. Yes, furan is also aromatic. Good. But furan will not be hydrocarbon because you have oxygen coming up. So it will go in the league of heterocyclic compounds, heterocyclic organic compound. If you talk about hydrocarbon, I have to stick to carbon and hydrogen only. Okay. Arjun, is it clear?
Yes, sir. So
Yeah, now Arjun is visible. Good, good, good. So any difficulty in this part? Aliphatic, aromatic is clear. Aromatic we have done. Cyclic. Akshay, you are there?
Yes, sir.
Okay. Can I shift the camera towards you? It's like I can see your backside wall and all, but not you.
Sir, my neck will start hurting if I like turn like that.
Okay.
Yes.
दिक्कत है देखिए अलग दिक्कत है इसकी चलो anyways aliphatic aromatics clear any problem in this part any issues now moving ahead can I proceed further and there's a term written for aliphatic there are three things you are going to study alkane alkene alkyne and there's cyclic analogs called cycloalkanes cycloalkenes and cycloalkynes okay cyclo means ring structure now please write down a question for yourself write down C4H6 try to draw all possible structures quickly 1 मिनट लेना ज्यादा मत लेना फटाफट सॉल्व करो C4H6 try to draw all possible structures C4H6 try to draw all possible structures Sanjana will tell what is the thought process. How many unsaturations? 5 minus 3. 2 unsaturation. Now 2 unsaturation can be 1 triple bond. Can be 2 double bonds. Can be 1 double bond, 1 ring. Can be 2 rings. These are 4 points that you should think of because of this 2. Note down. A triple bond has 2 unsaturation. 2 double bonds each will give you 1 unsaturation. So total 2 unsaturation. Similarly, 1 ring and 1 double bond or 2 rings. They all are having 2 unsaturation. Is this clear? Any problem in this part? Akshay ji clear? Arjun clear?
Yes,
So if you
sir.
draw first case में संजना ने बोला कि भाई ब्यूटाइन बना दो बिल्कुल ठीक बात है ये बना सकते हैं ये भी बना सकते हैं 2 डबल बॉन्ड केसेस बैक टू बैक डबल बॉन्ड हो सकते हैं alternate double bond हो सकते हैं you draw these structures will all be C4H6 put hydrogen you'll get C4H6 right Can you complete the other two? Do it, fatafat kariye. Why Adya is not joined? Not online, not offline. Okay. One double bond, one ring. So let's say 4 members are like this. आप एक double bond बना दीजिए. किसी ने बोला नहीं 3 member बना रहा है. कर सकते हैं. All these structures will satisfy C4H6. How about 2 rings? No
So
structure?
it will be like a parallelogram, right, with the diagonal.
So basically you can draw this and this. This is C4H6, right? It's a bicyclo compound. 2 hydrogens here, 2 hydrogens here, 1 hydrogen each. Okay, this is C4H6. And these are 4 carbons. Carbon, 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 and carbon. Fine. So can I say they all exist as aliphatic structures? They're all aliphatic hydrocarbons. They're all hydrocarbons. They're all aliphatic hydrocarbons. Few are alkynes, few are dienes. Di means 2, enes means double bond. Few are dienes. And few structures are bicyclo. Okay. And few structures are cyclic alkenes. Ring with double bonds. Isn't it? Any difficulty in this part? Is this clear? कर लेंगे. चलिए आगे बढ़ते हैं इस पे further. So can I remove this? Sanjana, done? Okay. So alkanes are open chain structure comprising of homologous series. Homologous series basically the difference of CH2 is there. CH4, C2H6, C3H8, C4H10. The gap is how much? CH2. So whenever you write them, you'll find a gap of CH2. It's like CH4, C2H6, C3H8, C4H10. So just see the gap, CH2. Every time you'll find a gap of CH2. And this is called homologous series. Fine. Any difficulty? And they're also known as paraffins. So this term you should know. Alkanes are also called paraffins, right? All right, moving ahead. So again, whatever things we have done earlier, we will not invest time and energy on that part. We will try to keep it very much structured for hydrocarbon. Okay? कोशिश करेंगे कि हाइड्रोकार्बन वाले टर्म्स को ही समझने की कोशिश करें अच्छे से. That will be better option. All right. चलिए. Can I proceed further? So now you can see here, as per IUPAC system, aliphatic compounds named as alkanes, and in this case, the first 3 members do not exhibit isomerism. All other members show chain or nuclear isomerism, right? So basically, nucleus and nucleus is different. So now just see, isomers pentane 3 मिल रहा है, hexane में 5 मिल रहा है, heptane में 9 मिल रहा है, octane में 18 मिल रहा है. Can you just quickly revise it and do it? Quickly revise heptane 9 isomers. फटाफट draw करिए. Quickly revise this part. Shyam and Adya, turn on the cameras. Can do it. Heptane. How will you draw heptane? Hept means 7. 1, 2, 3, 4, 5, 6. She has drawn already 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. This and this. How different are they? Middle carbon, you have 2 carbons. Middle carbon, you have 2 carbons. 5 in a straight. What is the name of this compound? 3,3-dimethyl pentane. What is the name of this compound? H मत लिखिए, H लिखिए आपका time waste होगा. Just write carbon. H automatically will fall in place. Don't worry. Okay, do it. Please try and understand. How many of you are able to draw 9 structures? Raise your hand. Okay. So 8 structure are easy. One structure which will be a problem, we'll see. First you draw 8 structures. So first structure is 7 members like this. 4, 3, 7. 6 and 1 branch. 6 and second branch. 5 and 2 branches together. 5 and 2 branches in the middle. Then 5, 2 branches adjacent. Then 5, 2 branches alternate. You understand the pattern? Simple. Then 4, 3 branches. So 1, 2, 3, 4, 5, 6, 7, 8. ये 8 structure तो सबसे बन जाएंगे. What is the 9th structure? Anyone can tell IUPAC name of the 9th which is not drawn? Chinmay?
Sir, am I audible?
Yeah, you're audible. What is the 9th structure? Which structure is not drawn here?
Or cycloheptane.
Cyclo नहीं बन सकता बच्चे. Cyclo ring कैसे बन जाएगी? तो unsaturation is 0.
You put an ethyl on one of them, like 5 in a row, and then ethyl on the center.
Ah, very good. What is the name of that compound?
So
3-ethyl pentane.
Sir, 3-ethyl pentane.
Yes, this is something which you can miss, which normally students miss. Okay, this compound is 1, 2, 3 ethyl on third position, 4, 5. So it is 3-ethyl pentane. First one is heptane, second is 2-ethyl hexane, third is this is 3-ethyl hexane, this is 2,2-dimethyl pentane, this is 3,3-dimethyl pentane, this is 2,3-dimethyl pentane, this is 2,4-dimethyl pentane, this is 2,2,3 trimethyl butane, and this is 3-ethyl pentane. कर लेंगे. IUPAC name आपको basic तो clear है सभी को. Anyone facing difficulty in IUPAC naming? Sanjana, is it clear? Names are clear. The 7th structure is clear. Is it optically active or inactive? Is it optically active or inactive? Inactive, because see, for optical activity, I need a carbon with 4 different groups. You have 3 groups same, so it is inactive. Is it chiral or achiral? Achiral. Okay, done. Chale aage. Shall we proceed further? Have you written this? Okay, great. Now confirmations, we have done this. If you recall, we have done eclipsed, staggered and all, right? So horse जब कराया था मैंने सारा कुछ कराया हुआ है. So we'll not discuss it. We'll move forward. Eclipse का मतलब क्या होता है? When you have two structures back to back like this. Staggered is when alternate position. Can you recall that? So for example, if I draw a structure like this, this is eclipsed. CS3 behind CS3, edge behind edge, edge behind edge. Okay. What is staggered structure? Staggered is if you draw like CS3. So see, CS3 opposite to CS3, H opposite to H, and H opposite to H. This is called staggered. If you see from one of the sides, you'll find this structure in the Newman projection as overlapping structure. Right? It will be CS3, CS3, H, 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 H. They're like ones behind the other. Can you recall? In this case, if you see, what will it look like? This kind of structure. CS3 top, CS3 bottom, H, 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 H. Have you done such things or not? ये सब मैंने आपको जीओसी में पहले ही इसलिए करा दिया था कि जब हाइड्रोकार्बन आए तो उसकी बात ना करनी पड़े, राइट? बट एनीवे आई एम जस्ट रिवाइजिंग सो दैट यू कैन कोरिलेट. Sham, is it clear? Akshay, Chinmay, Arjun, Adya, is it clear? Everybody this side, Arav, Yanka, Sanjana, clear? Can you proceed further? So which is more stable? Staggereds are more stable because of less repulsion, and eclipses are less stable because of more repulsion. Moving ahead. So see once again, this is eclipsed and this is staggered. Okay. All right. In Newman projection, you can see this is eclipsed, this is staggered. Make sense? Okay. Now these are some names for alkenes, which is very simple for you. I don't see you need to write down or something. But try to solve for these two. करिए. इस question को solve करिए. Write IUPAC name of this compound in your notebook. Draw this and write the name. Draw the compound, write the IUPAC name of this compound in your notebook. Done? Chinmay, what's the name of the compound? Chinmay, what's the name of the compound? Unmute and answer.
Sir, am I audible now?
Yeah, you're audible.
I think you're obscuring the screen a bit.
Yeah. What's the name of the compound? Draw this in notebook and then answer. Don't try to answer on screen directly.
So is it 2,4 dimethyl pentane?
Dimethyl pentane. Dimethyl pentane? Huh? So which is a long chain? First you see the long chain. Anyone else would like to tell?
So 2-ethyl 2,4,4 trimethyl pentane.
No,
Yes.
ethyl you should make part of long chain, Sham. You're doing mistake.
Oh,
And
yes.
those who are telling pentane, that's also incorrect because long chain will have 1,
Sir, I didn't see the ethyl. I took that group
Oh.
also as methyl only.
5, 6.
So it's
There are 6 carbons
so
actually.
it's 2244. So it's like quadromethyl hexane.
Tetramethyl.
That
Yeah. So the structure is like this. See. So it is 2244 tetramethyl hexane. 4 methyl ho gaya na? This is the long chain. Is it clear? Please note down the structure. 2244 tetramethyl hexane. Is it clear? C2H5, you have to write it as CH2CH3. They have written C2H5. You should write CH2CH3 by replacing it and then count the numbers. Why you're counting from this side? Why not from this side? Okay, because this side I'm getting on 2nd position branching and then 4th position branching. This side I'm getting 1 to 3rd position branching and 5th position branching. So there is something called lowest sum rule. We have done lowest sum rule, which tells very clearly that we should minimize the total values, right? So answer is this. Okay, do one more question quickly. Answer this. This time without any mistake. This time without any mistake. Tell the name of this compound.
so shall I send it to you or shall I say it here?
You can tell. You can tell.
So it's 2-ethyl 4-methyl pentane.
2-ethyl 4-methyl pentane. Okay. 3-ethyl 4-methyl pentane. Okay.
So is it
Others.
3-isopropyl pentane?
3-isopropyl pentane. एक branch कर दिया आपने, 2 branches को pentane बनाया. So remember, when you have option of more branching, you'll prefer more branching, Arjun. Okay.
Yeah.
Pentane ही है सभी के लिए, but if you have more branch, Arjun, so you should go for more branches if possibility is there. If not there, then fine. If longest chain is not supporting, then fine. So what should be the name? Correct answer to this is 3-ethyl 2-methyl pentane. लिख लीजिए. 3-ethyl 2-methyl pentane. Why 3-ethyl 2-methyl pentane? So understand, यहाँ से शुरू करोगे आप. Second and third. 2 plus 3 is 5. आपने बोला था 3-ethyl 4-methyl, which will 3 plus 4 is 7. This is just 5. Okay. Alphabetically E and then M. Right? उस order में लिख दिया. कर लेंगे? Can I proceed further? So these are some basic terms for naming, IUPAC naming or nomenclature of alkanes. Moving forward, इसको भी कर लो. इस बार गलत मत करना कोई भी. Please give me the right answer for this question. करिए. I hope the question is visible to all of you. Akshay, can you answer this question? Try.
So, sir, 3,4,7 trimethyl nonane.
Trimethyl?
Nonane.
Nonane. Okay. Others? ठीक बात है या कुछ गड़बड़ है? ठीक है. Answer is 3,4,7 trimethyl nonane. Good. That's the answer. 3,4,7 trimethyl nonane. Non is 9 members. 1, 2, 3, 4, 5, 6, 7, 8, 9. Third position पे methyl, fourth पे methyl, seventh पे methyl. So correct name. Okay. Non means 9. Dec means 10. Undec means 11. Dodec means 12. Like that means. Is it okay? कर लोगे? चलें आगे. Are it clear? Okay. Now, physical nature or physical properties of alkanes. Again, do not try to copy everything. I'll share this PPT with you also. You can use it. But try to understand most of the things in class. लिखो बस important चीजें लिख लो जो आपको लगता है कि हाँ ये see it's not like you should not read anything, but don't write everything also. Okay, at the same moment. So what is meaning of physical properties? Basically, we talk about density, solubility, boiling point, melting point, these are all physical properties. And then when you say chemical reactions, that will be chemical properties of a given compound. So alkanes, what are physical properties of alkanes? What all things will come up? So they are all colorless, possess no smell, right? Lower alkanes are gases, middle are liquids, and higher are solids. So logically speaking, molecular weight कम होगा तो क्या होगा? Gases, high, liquid, and उसके बाद solids में conversion हो जाएगी, right? And then the boiling point of alkanes increases with increase in molecular weight. What is the reason for this statement? How do you decide the statement? Why? So the reason is van der Waals forces. So write down, if size of molecule will increase, molecular weight generally increases, van der Waals interactions will be more, boiling point will be more. Okay. If symmetry is increasing, then dipole moment will be lesser, then dipole-dipole interaction will suffer, and then boiling point will be low. ये दोनों factors आपको पता होने चाहिए. अगर नहीं पता तो please note कर लीजिए. So more symmetry, and more symmetry will be linked with more branching. इसको symmetry को वैसे मत लेना, take it as branching. So more branching, dipole moment will be lesser, dipole-dipole interaction will be lesser, boiling point will be lesser. No, surface area will decrease. More branching means it will be, see, one is a long compound, you make it a small compound. So what will happen? Yeah. It will become compact. I'll use word compact. Okay. So symmetry is more, branching is more, dipole moment is less, DD interaction is less, boiling point is low. Size is bigger, molecular weight is bigger, van der Waals forces are bigger, boiling point is more. Now another term you should know is melting point. Symmetry is more, packing is better, melting point is high. That's a different observation. Better symmetry, better packing. Better packing, higher melting point. Adya, is it okay? Arjun, is it okay? Chinmay, is it okay? Sham, Akshay, everybody? Great. So they've written molecular weight of heptane is more than hexane is more than pentane, and hence the boiling point. Make sense? Simple सी बात है. But सोचो अगर आपको heptane दी जाए, and in heptane, I give you one straight heptane like this normal heptane वाला structure, and then I give you this structure, which will have higher boiling point, A or B? Which will have higher boiling point? Read here. More symmetry, more branching, lesser dipole moment, less interaction, less boiling point. Okay, which will have higher? Both are having same molecular weight. So which will have higher boiling point? A. Which will have lower boiling point? B. Because more symmetry. Clear? Higher boiling point किसका होगा? A का. Because अब ये मत बोलना कि यहाँ पे देखो symmetry है तो सर इसके about ये symmetrical है. That's not the case. It's all about branching. That's why written very clearly. Take it as branching. Okay. Don't see in isolation. Is it clear? Neopentane has higher boiling point than normal pentane. True or false? Neopentane has higher boiling point than normal pentane. Neopentane is this compound. Neo is like carbon with this branching. Normal pentane is a straight chain. False. Answer is false, right? Because neopentane will have lesser boiling point.
Sir, you're frozen.
Sir, you're on mute.
Can you hear me now?
Yes, sir, now it's fine.
So can
Yeah.
you shift the video a little bit to the right? So the last right side of your screen is like a little bit cut off.
Okay, just a minute. Oh, we should have told earlier. Okay. So it's a camera issue. Or disturb too much. Check now.
Yes, sir. Now it's fine.
It's better.
Yes, sir. It's fine. Thank
Now it is better. Chale. So let's see. This part is clear. Now coming to melting point. Melting point is altogether different when you talk about it. Melting point is about packing, right? And packing कैसे होता है? Just see. So if you have, let's say, this kind of setup, 4 members. In whatever you try to pack them, it will be easy, right? Just think about odd numbers. Odd number, both the sides are coming to the same side. Can you find this problem? Here they are both away from each other. So when you try to create a compact packing for them, it's easier here. Here it is difficult, right? And when the packing is better, if you can pack it better, its melting point will be higher. So I'll just go to that next part. Yeah, I'm coming to that. So write down physical properties. Branching in alkane gives a decrease in surface area, and hence you know that the van der Waals forces will decrease. The boiling point of isomeric alkane show the lesser value. Pentane, isopentane, neopentane, the sequence will be highest for pentane and then decreasing, right? The melting point of alkene do not show a regular trend. Even number of carbon atoms have higher melting point than their adjacent alkenes to the odd number. Okay. So बहुत तेज नींद आ रही. Yawning like anything. 10 times yawn कर दिया class में. Okay. Why you not slept properly? So melting point trends are slightly complicated. Hence, you should have just the basic idea about it that, okay, if Arjun, I can't see you. So
Just one
basically,
second.
yeah. So for melting point order, you have to understand that if it is even number, packing is better. Just see, this end and this end cannot be on the same side. So when you talk about molecular level packing, they will never ripple. These ends will never ripple each other, right? In any case, right? Hence, this packing is far more better as compared to this packing. यहाँ पे ऐसा वाला केस भी तो बनना शुरू हो जाएगा, बट वहां पे बना के देखो ऐसा केस नहीं बनेगा. Is it clear? Right? So adjacent even numbers are slightly higher. But again, if you see adjacent even number, let's say you talk about ethane and propane. Take these examples. Which is higher? Ethane is minus 172. This is minus 187. This is higher. But when I go to methane, then how much it is? Minus 182. Okay, यहाँ पे sign reverse कर लीजिए. ठीक है? So ethane is better than nearby both the members. Is it clear? This sign is to be reversed. ये इससे बड़ा हो गया ना भाई. ये नेगेटिव है, ये भी नेगेटिव है, ये नेगेटिव है, राइट? सो नेगेटिव के हिसाब से कंपेयर करके देखो. एनीवे, मूविंग टू द नेक्स्ट पार्ट. Can I go to the next part? You can just read this as a reasoning here in this paragraph. So odd number of atoms have their n carbon on the same side of molecule, and even number of atoms have n carbons on opposite side. The same thing which we have drawn a few minutes back. Okay. Now coming to density. Density of alkanes are less than water. Water की density कितनी होती है? 1 gram per ml, 1000 gram per liter, right? 1000 gram per liter. What is molarity of water? Arav? Molarity of water we have done in ionic class. How much molar it was? Water becoming H plus OH minus?
So 55.55.
55.55. Very good. 55.55. 1 gram per ml, 1000 gram for 1000 ml, which is 1 liter. 1000 gram upon 18 was moles per liter, right? Density is around 0.76. 0.76 is the density for this. Thus all alkenes are lighter than water. Alkenes are lighter than water. ठीक बात है. इसमें कोई बहुत special.
So
Sorry, alkanes are lighter than
alkanes or
water.
alkenes?
Alkanes are lighter than water. ठीक है. कोई मुश्किल बात तो नहीं है. अब आ जाइए solubility पे. Solubility. Now remember, alkanes are non-polar and thus insoluble in water, but soluble in non-polar solvent. This is a property from chemical bonding where we say LDL. Anybody remembers LDL? Yes, it's like dissolves like. Okay. Okay. So let's say एक पढ़ने वाला बच्चा, जैसे अक्षय पढ़ने वाला बच्चा, तो उसके फ्रेंड कैसे होंगे? सारे पढ़ने वाले होंगे. ठीक है. शैतानी करने वाला बच्चा होगा तो फ्रेंड कैसे होंगे? शैतानी करने वाले होंगे. राइट. Like dissolves like. Polar dissolves polar. Non-polar dissolves non-polar. Okay, this is how we say like dissolves like. So let's say you take something which is polar, it will be more interested in polar molecules to form stable structures. Water and alcohol mix very well. Reason? Like dissolves like. Benzene and water do not mix properly. Unlike, do not dissolve. Simple. Adya, is it clear? Akshay, is it clear? Sham, is that okay? Arjun and Chinmay. Chinmay, is it fine? All right. So like dissolves like. And one more line is written here. Anybody who can tell me the reason for this? Think and tell me the reason. The solubility of alkenes decrease with increase in molecular weight. Why? ऐसा क्यों कि molecular weight बढ़ने पे solubility कम होती जा रही?
So because the van der Waals forces are increasing.
Okay. इधर पे कोई बोल रहा था online?
So because the van der Waals forces are increasing.
So solubility should be more or less.
So less.
Why?
So because it will be harder for them to get mixed with the solution.
Ah, good. It will be basically interacting with itself, right? So the big size molecule is there. So van der Waals forces among the molecule will be higher. It will not interact with the nearby member. Is it clear? So solubility will be complex. Other logic can be if you have, let's say, long carbon chain and you try to dissolve in some small solvent, then this whole thing is complicated to get dissolved because of its size, enormous size itself, right? आगे चलते हैं. Liquid alkanes are themselves non-polar solvents. ठीक बात है. अब आ जाइए आप नेक्स्ट इंपॉर्टेंट पॉइंट पे, which is अब यहाँ से काम की बात शुरू होती है. अभी तक जितना भी पढ़ा उससे कोई भी क्वेश्चन कभी नहीं आएगा. बोलोगे फिर क्यों पढ़ा है? But because that's the process, right? So you'll not expect any question from what all we have done so far. Hardly one or two questions. कुछ छोटे मोटे क्वेश्चन आ गए तो आ गए. That is not very important part. Important part starts now, which is the chemical reaction. Let's start. So write down the heading. Reduction of alkyl halide is the first preparation method of alkane. What are we trying to discuss? Preparation method of alkane. What is the first method? Reduction of alkyl halide. आप alkyl halide को reduce कर रहे हो. यहां से काम की बात शुरू होती है. Mechanisms, reactions ये सब आना शुरू हो जाएंगे धीरे धीरे. So the first is reduction of alkyl halide. लिखिए. What is alkyl halide? Sham, can you give me example of any alkyl halide?
Sir, for example, CH3Cl.
Very good. CH3Cl is an alkyl halide. Any alkyl and halogen. Alkyl halide हो गया. कर लेंगे. Sanjana, is it clear? So if you have RX, so इसका general form हम लिखते हैं RX. R is basically alkyl and X is for halide. This is for alkyl and this is for halide. Please note down. Okay. This can be reduced into corresponding alkanes by following reducing agents, right? So what is reducing agent? Reducing agent is known to reduce the given thing. अच्छा एक बार quickly एक बार revise करते हैं. What is reduction oxidation? Who will answer? Niharika, can you answer? How do we differentiate reduction and oxidation? So reduction is basically Addition of hydrogen, loss of oxygen, gain of electron, decrease in oxidation state. Correct? We know that. So the agents which can do reduction for you are known as reducing agents. Okay, these are reducing agents. अब यहाँ पे एक लिस्ट दी है मैंने, इसमें इंपॉर्टेंट कंपोनेंट मार्क कर देता हूँ 1 2 5, ऐसे तो सारे ही हैं बट आपके काम के लिए इतने सारे एक साथ नहीं सीख पाओगे. So go slow, at least write these 5. I can give a list of 50 or 100 also at this moment. That is useless because that much information you can't carry. You should not carry also. So try to understand one by one all the things in slightly more detail. Let's write down the first member LiAlH4. लिखिए LiAlH4. एक एक करके वापस मैं आऊंगा स्लाइड पे. Don't worry. So let me go back and again we'll come back to this after a few minutes. So please write down LiAlH4. This compound is called Li say lithium, Al aluminium. Okay, hydride tetrahydride होता है, उसको hydride बोल सकते हैं. In short, it is called LAH. And now you are actually putting your footsteps in after GOC in actual organic chemistry. So in the terminology of organic chemistry, I'll use a word VSRA. These kind of words will keep on coming now. Write down VSRA. VSRA is basically very strong reducing agent. VSRA means very strong reducing agent. Now the question is why it is so strong reducing agent and what exactly it can do. Okay, so इसके कुछ खास बातें देख लेते हैं. So this compound is known because of its structure, which is Li plus and AlH4 negative. Yeah, I'll come to that. So first you draw the structure. LiAlH4 is like this. Please draw the structure. अब ये सब आपको पूरा पता होना चाहिए डिटेल से. स्कूल एग्जाम में नहीं पूछेंगे, मुझे पता है. वी शुड नॉट केयर अबाउट स्कूल एग्जाम की, इतना वही करना जो स्कूल में आ रहा है. वी हैव टू गो इन डेप्थ नाउ. So write down LiLH4 structure. You should know because this will keep on coming number of times. So you should be ready with that. Now after writing this, write the next point. Reacting component. Here is H negative. So the reacting component is H negative in this case. H negative is going to react. Okay. H negative react करेगा. कहाँ से निकलेगा H negative? ये रहा H negative. ये अटैक करता है. Now if you recall GOC, there are two things which we have not done. One was SN, other was SFR. Substitution nucleophilic, substitution free radical, right? So what is substitution free radical? If you're given any RX, if I bring a nucleophile that can go and attack and remove X. In this process, X minus is out. So can you observe in this reaction, a nucleophile is substituting X by replacing it? Can you observe? Nucleophile, you know. How many types of nucleophile are of? Are nahi bhai. Three types of nucleophile. Actual negative charge, double or triple bonds, or ring systems. Can you recall? Okay. Pi electron systems, basically, or ring systems. So nucleophiles, or sorry, lone pair systems. Lone pair बोल सकते हो इसको. So Rx पे attack किया, NUR बना और X minus बाहर गया. What is this called? This is left. It is called leaving group. Note down. This is known as leaving group. A group which leaves an attack. So in this reaction, who is attacking Niharika? In this case, what is attacking where? Nucleophile. Attacking where? Rx. And what it is doing? Is it being attached with X or it is replacing X? So replacement is also called, Sanjana, replacement is also called substitution. So it is nucleophilic substitution. Understand? This reaction is classified as nucleophilic substitution. Is that okay? Akshay, Chinmay, Arjun, great. So this is nucleophilic substitution where H minus is going to replace it. So how is the reaction going to process? If you take any Rx, ये H minus जाएगा, इस R पे attack करेगा, इस X को free कराएगा, and it forms RH and X minus. तो क्या मिला मेरे को? RH. What is RH called? Alkane. So let's say you have started with something like CH3, CH2, Cl. So what's my answer here? CH3, CH2H, which is basically ethane. Is it clear? H minus goes, replaces Cl, joins there. Sanjana, is it clear? Niharika, is it clear? So this is basically lithium aluminum hydride coming and replacing X in this case. And it's a reducing agent. Why it's a reducing agent? It's a provider of H minus. Hence, I'm calling it reducing agent. Okay? पूरा process समझ में आया?
So is it a SN1 reaction or SN2?
That we'll discuss later. Okay? That will be the part of 12th standard, which will start with alkyl halide. अभी SN1 SN2 मत सोचो because वो थोड़ा ज़्यादा complex हो जाएगा बाकियों के लिए. ठीक है?
So, but
Yeah. Normally speaking, this is SN2 reaction. It can't be SN1 in this way. Okay. If you know SN1, SN2, this is SN2. Okay. SN1 is where we form carbocation, rearrange, and then do the reaction.
yes, so that's bimolecular, right?
Yeah. SN1 is having basically SN1 is order is 1, steps are 2.
Oh,
SN2 is
yes.
order is 2, steps are 1.
Yes.
Okay. चलो इस पे हम discussion करेंगे. First, is this part clear? LH is clear. Now, what was next in the list? If you recall, the next in the list was NaBH4. Check कर लीजिए अपनी list if you have written the list. So write down the heading NaBH4 and try to learn about NaBH4 also a little bit. See, whatever I'm discussing, again, this discussion will go in much more detail as you progress in your journey. But अभी के लिए इतना काफी है. तो लिखिए NaBH4. Okay. What is this? Oh, ये भी हो सकता है. हाँ?
Sir, you have taken the text. So change the background.
अच्छा अच्छा. This part. अच्छा, oh, okay, 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 fine, yeah. Write down sodium borohydride. Sodium borohydride. Okay.
First group and then the group and then.
We'll talk about that. So sodium borohydride is Na plus and BH4 minus. This is the structure. This is also a strong reducing agent, but I'll not say very strong. I'll use word SR. Strong reducing agent. Okay. RH will form and X minus. So what I'm getting here again, we can get alkane. It again gives us alkane. Fine. समझ में आ गया? Similarly, sodium alcohol, if it is given sodium alcohol, that can be again reduction. Just a minute. Sodium borohydride. So H minus is replacing like this. Now, other members, if you see the list, other than this, you will find we have written sodium alcohol, we have written zinc CS3COH, we have written MgHg water and all. So these things will keep on coming. Don't bother too much about everything at one go. In your book, I'm pretty sure they must have mentioned one or two. Okay. Have they mentioned more than two or three? I don't think so. Now, there are 2-3 very important parts that you should know at this moment. So write down here. Yeah. Yeah, please. Rx. You understood? Okay. Rx cannot be 3 degree. Rx cannot be 3 degree. अब ये Rx 3 degree क्यों नहीं हो सकता? देखिए, Rx cannot be 3 degree. अब इस पे आते हैं कि Rx 3 degree क्यों नहीं हो सकता? इसका रीजन समझने की कोशिश करते हैं. Okay. So what's the reason for that? Rx cannot be 3 degree means, let's say I give you something like this kind of R. So this carbon is a 3 degree carbon and this X is connected with a 3 degree carbon. So this is a 3 degree halide, right? So this kind of Rx are not allowed. Rx cannot be 3 degree for these kind of reactions. Can anyone tell me the reason for the same? Yes. So why will it not leave? That's the question. Bond is stronger. Why bond is stronger? So then it should easily break, no? It should break. आराम से plus charge बना लेना चाहिए था इसको. If it is not the case, right? So here comes another concept. This is concept of elimination. Okay, there is something called elimination reaction. Right on the heading. Elimination reaction. Okay. Elimination reaction. So if you go with 3 degree option, let's say you have this kind of situation. In presence of H minus, it can undergo elimination. What is elimination? This comes, takes H, create a double bond, send this free. So what will it become? It becomes CH3, CCH3, double bond CH2. So actually you were expecting alkane, but you started getting alkene along with hydrogen. Understanding? These kind of reactions will start. Okay. So in 3 degree cases, these reactions are more feasible as compared to 1 degree and 2 degree cases. अब इसके पीछे रीजन क्या होता है, वजह क्या होती है, उसके लिए आपको समझना पड़ेगा एलिमिनेशन रिएक्शंस क्या होते हैं. Okay. So elimination reactions can be categorized in 3 ways. One is called E1, other is called E2, other is called E1CB. These are 3 main. Note down. E1, E2 and E1CB. These are 3 major variety of elimination reactions. अरे आपका ब्रेक रह गया आज. चलो छोड़ दो, क्या कर रहे हैं. ब्रेक. ओके. सो ये लिख लीजिए, फिर आप ब्रेक ले लीजिए, बिकॉज आई कंप्लीटली मिस्ड. ब्रेक छोड़ा कर ले थोड़ा, 10 मिनट का कर ले मैक्सिमम. 3:19 पे वापस. 3:08 हो रहा है. No, I'm just trying to discuss something. Yeah. We'll start from here. 3:19. E1CB. Chinmay, Shyam, Akshay, Arjun, Adya. Let's start. So we were talking about elimination. What is elimination? So just mention 3 types of elimination are there: E1, E2, E1, CB. Now, what is E1, E2, E1, CB? That is 12th standard portion. We'll do in 12th standard. Will not bother right now. Okay. कि अभी आपको exactly अभी नहीं समझ लेना because that's part of 12th standard mostly. In detail we'll do. But what is elimination? You should understand the basic idea. So what is basic idea of elimination? So if you take any alkyl halide, let's say we take this kind of setup. So ध्यान से समझना है इसको. Okay. Just pay attention to this hydrogen and this X. So if I bring any strong base or base can go pick hydrogen, create double bond, and X is out. Okay. Now I repeat, base will go pick hydrogen. Now which hydrogen? This is carbon. इसकी alpha position में चले जाएगी. इस पे जो hydrogen, ये H ले रहा है, यहाँ पे एक double bond form हो रहा है और ये X बाहर हो रहा है. What is the benefit out of it? What are we going to get out of it? Is this kind of compound, which is a double bond. So this process is elimination. What are 3 major components of this process? So one component is base. Second component is this particular alkyl halide. Yeah, I'm coming to that. And the third is X. 3 parts of this, right? Which is leaving. So have you done E1, E2, E1, CB in school? No. Okay. So these are 3 parts. Now just look at my hand and try to understand this in some different way. So एक पेन देना मेरे को कोई सर. Yeah.